Hey everybody, sorry about that. I don't know what's going on with the internet there, but so this is where we left off. We're talking about the leading coefficient and the degree. So for the degree, all it is the highest exponent in your polynomial. Now there is a small catch, is it does have to be on a variable, but if you've simplified, that shouldn't be a big deal because you shouldn't have any other exponents. So if we're looking at these, this one, for example, would be degree 1 because we have that 1 there. This would be degree 2 because I have a squared. And these are both degree 1, so it would be a degree 1 polynomial. But we're not going to worry about ones that have different variables, so you don't have to worry about that too much. And then down here, this has degree of 1, this has degree of 3, and degree of 0, because all constants have a degree of 0 because it's like x to the 0 power. So, or you can think about it as they have no variables if you wish. But, so the degree of this entire trinomial would be 3. Okay. So that's how you find the degree. You don't have to calculate anything. You just have to look for what's the highest exponent on one of the terms, on one of the variables. And then the leading coefficient, all you have to do is you look at where the term you got the degree from, and it's the coefficient of that term. Okay, so it's the coefficient of the term with the highest degree. Okay, so this one, it's 1x to the first, so since that had my highest degree, my leading coefficient, or LC here, would be 1, just like my degree is 1, but that has no correlation. So if I look at this binomial, my leading coefficient, we said my degree was 2, so I'm looking at the coefficient of that term, so that would be 3, because that's what leads into that term. And don't worry about this guy. Looking at this trinomial, our degree was 3, so I'm looking for the coefficient of that term, so that would just be 7. Okay. So when you're looking for the leading coefficient and degree, that's really all there is to it. You just look for the highest exponent, and then it's the coefficient and the exponent of that term. And then that takes us through all of Monday's topics. There is one technical new thing that I'm going to show you just really quickly about Tuesday's topics as the last topic of this week, since the rest will be a test review. And that's adding and subtracting polynomials. This is not new. You have been doing this, polynomials, not polynomials. You have been doing this for quite a while now. Okay. Adding, subtracting polynomials. Previously, you just called it combining like terms. Okay. That's all adding and subtracting polynomials is. Now, there's going to be some extra parentheses and stuff. Not a big deal. Half the time you don't need it. So if we're adding, we might have something like 3x squared plus 4x minus 1. That's our first polynomial, plus 2x squared plus 3, or something like that. Okay. So all they do with these parentheses is they put them in so you know where the first polynomial stops and where the second one is. So if it's addition, the first thing we're going to do is drop those parentheses. So we got 3x squared plus 4x minus 1 plus 2x squared plus 3. Then I'm looking to combine my like terms, so I got these two here. I like to use different symbols, whether it's different amounts of underlines or using boxes and circles or whatever, just visually to help myself, so I remember which ones I've used. So I have 3x squared plus 2x squared, which is 5x squared. Then I have 4x, and I have no other x's there to go along with it, so it's still just plus 4x. Then I have a negative 1 and a 3 as my constants, so they don't have any variables, so they're like terms. So negative 1 and 3 add up to 2. That's pretty much it for addition. Subtraction is almost the same thing. except when we're subtracting, we have to do one step before we drop our parentheses. So let's just do x squared plus 2x plus 1. So this one, you have to be very careful when you write this one out. I need to distribute this negative sign. So I'm going to make it plus and then flip all the signs on the inside. Okay. I can't get rid of the parentheses till it's an addition sign. So that's how I do that. I distribute this negative. So it's like negative 1 times x squared, negative 1 times negative 2x, negative 1 times negative, or times positive 1. And that gives you this new thing. So I'm taking the negative from the front and putting it in the middle. Notice it turns into an addition sign in the middle. It doesn't disappear. That is a very common mistake people make, is they're going to distribute this, and then they turn this into multiplication, which is what happens if there's no symbol there, and that's not what we want. So now it's addition, flip all the signs on the second one, only the second one, then it's the same as what I had before. So 2x squared minus 7x plus 3 plus negative x squared. And if you want to, instead of writing plus negative 2x plus negative 1, if you want to make the subtraction, you're welcome to do that. I'm going to go with writing them all out just for consistency's sake. But remember, adding negative 1 is the same as subtracting 1, and that's totally fine too. Now I'm going to line them up. So I did lines here, I'll do shapes here so you can see what I'm talking about. I have 2x squared plus negative x squared, which is positive x squared. I have 7x and negative 7x and negative 2x, which is negative 9x. And then my constants are circled, 3 and negative 1. So 3 plus negative 1 add together and you get 2. Okay. So either way you do that is totally fine. The only thing I do want to warn you about is if you're going to make a mistake here, I can nearly guarantee it's going to be with negative signs. So be very careful with your negative signs, whether it's distributing a negative sign or you're subtracting, adding a negative, whatever the case may be, watch those negative signs. That's where the mistakes usually fall.